Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and a very good day to all the participants in this hall today. So I'm Siti Elfiza Ashari from University Putra Malaysia. So I would like to present part of my students' research work entitled OLeate Loaded Polymeric Micelles in terms of optimization and evaluation using response surface methodology. So in this presentation, we'll cover the introduction, motivation and problems, research design, the methodology, results and discussions, and also the conclusion. All right, so as introduction, we have used the one of the main ingredient, which is we call it as kojic mono-oleate ester, or KMO, or we known as OLeate. Okay, so this is the structure where we can see this structure is actually, this ester is actually derived from kojic acid and oleic acid. So the kojic acid is basically produced from fungal metabolites such as from Aspergillus superiosa. So this OLeate is more stable in terms of storage stability, compatibility, and solubility. And also it is safe and non-toxic. It also has higher tyrosinase inhibitory activities in treating hyperpigmentation. As you can see here, this is the picture for hyperpigmentation disease such as melanin formation and so on and so forth. And this kojic mono-oleate ester also is one of the excellent brightening agent. So we managed to get this OLeate patented by Perbadanan Harta Intelek Malaysia. Alhamdulillah. So what is the motivations during this research work? Okay, as you can see here nowadays, so many local product in cosmetic product basically are not registered. The ingredient itself, they use mercury or hydroquinone, which is, it can give harmful to the consumer in very long term. All right, so we actually try to develop a new, safe, and efficient anti-tyrosinase agent for hyperpigmentation treatment under the rules of NPRA. And in terms of this, the ingredient itself, kojic acid ester has greasy feeling and larger droplet size, making it difficult to penetrate deeply into the skin. Therefore, we are trying to encapsulate, the motivation here is we try to encapsulate this OLeate with drug delivery system. But then the nano delivery system thermodynamically unstable with physical instabilities. Thus, the problem arises to maintain the required droplet size and good stability of the system. So in this research work, we use polymeric micelles in the formulation because it is a leading formulation system for efficiently delivering the active ingredients to the target area of the skin. And PMs are mostly formed by self-assembly of amphiphilic polymers, which is consist of hydrophilic region and hydrophobic component. So hydrophilic basically in the outer shell, whereas the hydrophobic basically in the inner shell or inner core. So the size basically from 10 to 200 nanometer, and the structure usually in spherical shape. All right. So PM also is very easy to prepare and practicability for a high scalable than the other nanocarriers. So one of the polymer we use in this research work is Polymer 407 because it contains of one hydrophobic region and two hydrophilic region. All right, so overall research design basically involved 4 parts, where the first one we have to synthesize the main ingredient itself, the OLeate, and then to design the formulation using polymeric micelle, and then we did a few in vitro and in vivo studies and also toxicity studies and molecular docking. But then in this research work, in this presentation, I would like to focus more on the formulation using RSM. polymeric micelle. Alright, so for specific research objective, the first one we want to formulate in the nanocosmeceutical of OLeate loaded polymeric micelle formulation. And then we want to optimize the formulation using RSM, response surface methodology. And the last one, we want to characterize the physical-chemical properties and evaluate the stability properties of this micelle formulation. So in the beginning, we did a preliminary screening studies where we have to choose the best polymer. All right, we have a few polymers and we select the Polosomer 407 as our polymer, our polymer. So we choose the composition between 2 to 9, 2 to 9 percent. Where we have here, we can see here we have 5 formulation A, B, C, D, and E, and the rest we kept constant. All right, so this is the preparation on how to do the formulation where we have the aqueous phase, and then we have the polymer and oil phase, and then we have to add a few preservative and fragrance as well. All right, so we use RSM using central composite design. This is for second objective. We want to design the RSM. Okay, RSM basically to determine the optimum formulation and condition for reliable results. And as you can see here, we have 3 independent variables, which is stirring time, stirring rate, and temperature with this region. Right, for example, time we use from 55 to 85 minutes, stirring rate from 1000 to 1500 RPM, temperature between 30 to 70 degrees Celsius. And in total, we have 20 experiment run, and droplet size or particle size can be used as a response. So after we design the region for 3 variables, then we come up with the actual droplet size. So this, as you can see here, we have in total 20 runs, and still the size for all 20 runs still within in nano size from 20 to 200 nanometer. And from the ANOVA, we can see that our model is significant with R squared around 0.8562. And this is the equations. And also from RSM, we can also see the interaction with response surface graph, interaction between 2 variables. For example, here we can see the trend interaction between stirring time and stirring rate while temperature was kept constant. So as you can see here, as we increase the stirring rate and increase the stirring time, the particle size will increase. And also for this trend, you can see the interaction between stirring time and temperature. So this is the optimum one. And also this curve between stirring rate and temperature with the droplet size. Okay, so for this objective, we managed to get this optimum condition where the stirring time is between 55.16, stirring rate between 1494.3 RPM, and the temperature 30.12 with droplet size 97.29 for actual and predicted for 92.84. And this is the validation design. We have 5 experiments in total, and we can see the RSE percentage is within the significant model. And the last one is in terms of its physical-chemical characterization. So we have the PDI value around 0.223 with zeta potential negative 5.18 plus minus 3.75. And the pH for our formulation, our optimized formulation is 5.69, where the suitable for human skin is between pH 4.5 to 6.5. So we can see that our formulation is within the suitable human skin, which is to avoid the skin irritation. And conductivity is around 0.284. And in terms of morphology study, so this is the TEM image of the optimized formulation. So we can clearly see that this is distributed homogeneously and it is in spherical shape. Okay, in terms of the stability study, we have used the centrifugation test So as you can see here, basically centrifugation test is for us to use to forecast the shelf life of the formulation. And the free store cycles, as you can see here, we have three formulation, free store of the optimized formulation. The A1 is after 1 cycle, B after 2 cycles, and C after 3 cycle. So we can see here before free store cycles, the nano size, the droplet size is around 97.29. But then after free store is slightly increased, but then still in nano size. So as conclusion, we managed to optimize the OLeate loaded PM formulation with desirable criteria for stirring time, stirring rate, and temperature with good RSE, less than 1%. And then in terms of physical chemical properties, was successfully characterized. So this is part of our achievement where we managed to secure a grant about 175,000 through Sign Fund, UPM IPM, and UPM LPS. And Alhamdulillah, our main ingredient, OLeate, has been patented. And also we got the market validation grant of about 70,000 and around 7 publications we managed to publish with this research. So this is award and recognition. And with that, I would like to acknowledge all these good and responsive collaborators, students itself, and also for the sponsorship. With that, thank you very much.